Okay, this is the opening lecture on lenses. Okay, there are two basic types of lenses, what are called converging lenses and diverging lenses. The classic example, first of all, of a converging lens is what is called a double convex lens. I have a nice demonstration example right here of a double convex lens. It is shaped like so. Okay, for this double convex lens, this converging lens, we want to first of all figure out exactly where the focus is. In order to find the focus, what we do is we find the image of a point object at infinity. Okay, so just beginning to take a look at lenses. Okay, as I said, there are two basic types. First, converging, and then secondly, diverging. So we're going to start with the converging lens. And the basic example is what is called double convex. The lens in your eye, for example, by the way, is also a double convex lens. Double convex lens is shaped like so. Okay, and then what we want to do first of all is we want to find the focus. In order to find the focus, what we have to do is we have to find the image of a point object at infinity. So in order to do so, we're going to have to draw a ray diagram. When I draw this initial ray diagram, I'm going to draw it nice and large, and the reason for that is because there are actually two refractions that occur. There's refraction, for example, first of all, from the air to the glass through the first surface, and then there's refraction from the glass back to the air here at the second surface. So for that reason, I'm going to draw my diagram here nice and large so we could see the individual refractions that occur. Once we understand, however, how the refractions occur, then later on I'll instruct you as to a shortcut as to how we can draw these types of diagrams with the refraction of light through lenses fairly quickly. And as we examine this topic on lenses, by the way, we're only going to consider one situation. That situation is going to be a glass lens that is in air. We're not going to take lenses and immerse them in water or do anything strange like that. So we're just going to have lenses that are made of glass and they're just in air. Okay, at any rate, however, let me go ahead and begin this basic ray diagram. Okay, so as I said, I'm going to draw this nice and large, like so. And then right here is my optical axis. Right here are right angles, like so. Okay, the index of refraction of the glass we're just going to refer to as n. Okay, and then recall from mirrors, if you have a point object at infinity, then all of the light rays coming from that object are parallel to each other and parallel to the optical axis. So I'm going to go ahead and draw three light rays like so. And we draw them symmetrically. Like so. And now I have to refract these three light rays across the first surface from air to glass. So I'm going to go from a low to a high index of refraction when I do. Now with respect to the light ray that is here along the optical axis, right here at this point the angle of incidence is 0 degrees. From Snell's law, the sine of 0 is 0, and then therefore the refracted angle is 0 degrees, which simply means that the light ray just goes straight through like so. Okay, and then we have this light ray right here at the top. Now what I have to do here, I'm going to use black to do so, is I have to draw my normal line. Right here is the dotted line that is perpendicular to the surface at that location. And now we're going from low to high index of refraction, so then therefore I have to bend my light ray or refract my light ray towards the normal line, towards the dotted line. So then therefore the first refraction for this top light ray looks like this. Okay, now I'm going to do the same thing for the bottom light ray. Okay, for the bottom light ray, right here at this point, I'm going to go ahead and draw my dotted line that is perpendicular to the surface like so, and then therefore right here is the angle of incidence. Once again, we're going from low to high index of refraction, so I have to bend towards the dotted line. Like so. Notice that these three light rays, here, here, and here, are beginning to converge. That's why this is ultimately referred to as a converging lens. But now I still have to refract these three light rays here across the second surface. For the light ray that is here along the axis, once again right here, the angle of incidence is 0 degrees, so then therefore the angle of refraction is 0 degrees as well, and this light ray just goes right through once again, like so. Let me draw that a little bit more solidly. Like so. Okay, now take a look at the top light ray. For the top light ray, this dotted line right here is perpendicular to the surface at that location, so then therefore right here is the angle of incidence. But now in this case, we're going from high to low index of refraction, so then therefore I have to bend away from the dotted line. This then means that this light ray refracts like so. Notice I'm bending it away from this black dotted line. Notice that the two light rays come together right here. This is pretty obviously where the focus is going to be located. Well, let me show the refraction here for the bottom light ray as well. Okay, right here at this location like so, there's my dotted line that is perpendicular to the surface at that location. And now what I have to do is I have to refract from a high to low index of refraction, so then therefore I bend away from that black dotted line. That then looks like this. And then these three refracted rays, here, 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 they converge together at this point, and this right here then therefore is the focus. The distance that the focus is from the lens is once again referred to as the focal length. As we'll see a little bit later on, there are two foci associated with each lens, one on either side of the lens, and the focal length distance is the same on both sides. Okay, now as you saw, drawing this out is rather difficult to do, and it's somewhat convoluted because I have to refract my light rays across two surfaces. And I did this, very strictly speaking, by using this diagram. However, we definitely shortcut these diagrams when describing the refraction of light through lenses. However, to describe these shortcuts, you have to know ahead of time what actually happens, which is this situation here. At any rate, however, let me just go ahead and draw the shortcut here associated with this diagram. It looks like this. Okay, so here's my lens once again like so. Here's my optical axis. And then once again, we draw three light rays. First light ray along the optical axis just goes straight through like so. Okay, and now for my second light ray here at the top, what we do as a shortcut is we draw it like so to the middle of the lens. And then when we get to that point, what we then do is we refract it through the focus. We already know that it exists from my previous diagram. We then refract it through the focus on the other side, like so. And then we do the same thing with the bottom light ray. We just draw it like so to the middle of the lens, and then refract it through the focus out the other side like so. And then here's the focus like this. Okay, now does this right here really happen? In other words, does the light ray just go straight through to the middle of the lens and then all by itself decide to refract out the other side like so? No. What actually happens, of course, is the previous diagram. But once we know that, then you could just go ahead and shortcut that diagram and draw the refractions like this, and that's perfectly fine as a basic shortcut. Okay, now essentially I'm going to do the exact same process here for a for a diverging lens. The classic example of a diverging lens is what is called the double concave lens. Okay, so now we're going to find the focus of a diverging lens. Okay, the classic example is what's called double concave. Let me just draw the basic shape of a double concave lens. It looks like this. It's shaped like so. And once again, the process here is to find the focus. We do so by finding the image of a point object at infinity. Okay, so like I did for the converging lens earlier, now for this diverging lens, I'm going to show you the process of, first of all, the two refractions that occur as we go from air to glass, and then from glass back to air. And then once you see what really happens in finding the focus, then I'll lead you through a shortcut as well. Okay, at any rate, however, we have right here, of course, our optical axis, where right here is a right angle. And then I've got my three incoming light rays parallel to the optical axis like so. Once again, this is for a point object at infinity. Okay, now right here with the light ray along the optical axis, once again the angle of incidence here is 0 degrees. The sine of 0 is 0, therefore the refracted angle is 0, and the light ray once again just goes right through. Like so. It does so on the other side as well. Let me just go ahead and immediately draw that, like so. Okay, now take a look at the top light ray. For the top light ray, right here at this location, right here is my dotted line that is perpendicular to the surface. So right here is the angle of incidence, and now I'm going from low to high index of refraction. So I have to bend towards the dotted line. So then therefore my refracted light ray looks like this. Notice that this light ray here and here, they're diverging from each other as opposed to converging with the previous situation. Pretty obviously, this is why this is referred to as a diverging lens. The same thing will now happen with this bottom light ray as well. So with the bottom light ray, right here at this location, there's my dotted line that is perpendicular to the surface, and now we're going from low to high index of refraction. So I have to bend towards the dotted line. That then looks like this. Like so. Once again, here, here, and here, these three light rays are diverging from each other. Okay, and now I have to refract them across the second surface. So take a look at the top light ray. Right here at this location is the dotted line that's perpendicular to the surface of that location. And now what I have to do is I have to bend away from the dotted line as I go from high to low index of refraction. That then looks like this. Same thing with the light ray here down below. This right here is my dotted line perpendicular to the surface of that location. We're going from high to low index of refraction. I have to bend away from the dotted line, like so. And then these three light rays, here, here, and here, they're all diverging from each other. So then therefore, if you were over here somewhere and those three light rays then entered your eye, you would then see those light rays as if they were coming from behind the lens on the other side of it, that is like so. What we do is we take these three diverging light rays and we extend them back behind the lens. So for the top one, that's like this. For this one here in the middle, that's like this. And this one here down below, that's like so. And then right there is the focus. Once again, the distance that the focus is from the lens is referred to as the focal length, small f. Okay, this is what strictly speaking happens with the two refractions, that is across the two different surfaces, but of course drawing this out is rather convoluted. So then, therefore, once again, we just construct a shortcut. Okay, we construct a shortcut, assuming that we already know that this right here is what really happens. But here's then how we draw this as a shortcut. Okay, so once again, here's my double concave diverging lens. Here's the optical axis. Okay, and then drawing these three light rays with a shortcut, we just merely do this. Okay, first light ray along the optical axis like so. Okay, top light ray, you just draw it to the middle of the lens like this, and then you just diverge it away out the other side like so. Same thing with the bottom light ray, just draw it to the middle of the lens like this, and then just diverge it out the other side like so. And then these three rays, here, here, and here, they then look like they're coming from back here. Like so. And that then therefore is where the focus forms. Now, does this really happen here? That is, does the light ray just all by itself decide to refract at the middle of the lens out in this direction? No. What really happens, of course, is the previous diagram, but now that you understand that that is what happens, then you can just draw the shortcut here as I've done for the diverging lens. Okay, I'm going to conclude this here as part one of this opening lecture on lenses. At this point, make sure that you take a look at my lenses demonstration video in today's folder.